Okay, so let's go look at a similar circuit that we just did. I'm going to add an additional resistor in it here at the end. R1, R2, R3, R4. Power source. We'll stick with 120 volts. I typically use 120, although you don't need to. I just do it because it's the US standard. Let's make sure I pick good numbers here. Let's go 12 ohms, 18 ohms. Let me. All right, I go 3.8 ohms. I go 2 ohms. I made this so it'll come out to nice numbers to work with. WebAssign isn't going to do that for you. Sorry, they're randomly generated. All right, we'll open up by filling out the known information in our chart. Whoa. Total. What did I get? 3.8, 12, 18, 2, 120. First thing I gotta do, get the total resistance. So let's do that. All the current, all of it, all of the current goes through R1, and then it splits here. It also goes through R4. So the battery or power source and R1 and R4 are in series. They have the same current. Okay. This is a parallel branch. I want to think about my analogy that I've been using. I'm not going to draw the 6 people. I'm getting tired of that. 120 down to 0. Okay. Everyone takes R1. When you get to R1, you have the option. You can take ladder 2 or ladder 3, R2, R3. Okay. And then from there, everyone takes R4. Okay. So everyone is taking 1. Everyone is taking 2. I'm sorry, is taking 4. 2 and 3, that's the option. So we're going to do a 1 over 12 plus a 1 over 18 equals a 1 over R. Grab the calculator, 1/12 plus 1/18, 0.138 repeating equals 1 over R. So R equals 1 over 0.138 repeating, or 7.2. All right, now, 1 and 4, we're just going to add them up because they're in series. So 3.8 and 2. So 3.8 plus 7.2 plus 2. So this is R1 plus R2/3 branch plus R4. If you think about it, it's kind of like a series circuit. It's just that the middle resistor is an option. So It's series in the sense that everyone's going through R1 and everyone's going through R4. It's just in the middle. All right, some people go 2, some people go 3. But then everyone's going to get back together and everyone's going to go through 4. This comes out to a nice even, if I did it right. Yeah, 13. I'm trying to make the numbers nice and I just screwed myself. Oops. All right, that's fine. We'll survive. Here we go. 120 over 13. 9.23. We just had a discussion a moment ago. All the current that goes through the battery is going to go through R1 and it's going to go through R4. So this will also be 9.23 and 9.23. Questions before I proceed? You really should be asking questions now because as I proceed and we get to the end, if you want to know, well, how did this number come back? Everything is very sequential. Okay. V equals IR. So 35.1 goes here. R1 will burn 35.1. 9.23 by 2. That's R4. That'll be 18.5. This one will burn 18.5. So let's take a look at, well, what does that mean? All right. This line here, 120 volts. The next line here, if I take 120 and I subtract 35.1, I get 84.9 volts. The line afterwards, I don't know what it is because I don't know what R2 and R3 consume, but that's okay because I can work backwards. This line here, 0. So why is 0 and why 120? Because the battery is literally taking 0 and it raises it to 120. That's what a 120 volt battery does. All right. So this line here, well, think about it, folks. If you have 0 volts on the left side of the resistor and the resistor consumed 18.5, then you better have 18.5 volts on the right side of the resistor. So R2 and R3, what did they do? They took 84.9 and they brought it down to 18.5. So they each consume 66.4. So this would be 5.53. This would be 3.69. Power, P equals IV, 35.1 by 9.23. So I got 324. 66.4 by 5.53. That'd be 367. 66.4 by 3.69. That's 245. 18.5 by 9.23. 171. 120 by 9.23. 1108. The confirmation check, 324 plus 367 plus 245 plus 171. I got 1107. I'm within 1 watt I think that's pretty good.